Let's talk about the shapes of graphs. This histogram shows the heights of a sample of 2,800 women. Notice they're clustered around 63 inches. Recall that the mode is the most common value. This is an example of a unimodal distribution. There's just one peak, one mode, and again, it's about 63. This histogram shows the weights of a large sample of adults. This is an example of a bimodal distribution. There are two peaks, one over here and one over here. Why do you think there are two peaks? I think it's because women tend to be over here and men tend to be over here. This is an example of a uniform distribution. There are really not any peaks. It's a simulation of 1,000 rolls of a die, which you'd expect to be uniform. We've seen that distributions can be unimodal, bimodal, or uniform, depending on how many peaks they have. We can also classify distributions in another way. This histogram shows the distribution of adult IQs. So again, clustered around 100. This is an example of a symmetric distribution. The left half is the mirror image of the right half. In this case, the mode is the same. The mode, this peak over here, is the same as the median. It's going to be the same as the mean because it's symmetric. This next histogram shows the distribution of annual household incomes in the United States for 2010, when the census was taken. And not surprisingly, this is not uniform. It's not symmetric. Instead, notice it's got this long tail here to the right. People who are making plenty of money. This distribution is skewed right. The right half extends further than the left half. It has a tail that extends to the right. We call that skewed right. In this case, the mode is going to be less than the median, which is less than the mean. The mode is over here. The median, because there's so much tail over here, the median is going to be more over here. And then the mean, well, the mean is going to be more over here, because the mean is affected by these extreme values over here. It's sensitive to outliers. This histogram shows the distribution of expected age of death in the United States if we start with a group of 100,000 people. So yeah, most people are going to, a lot of people are going to die around this age. Yeah, people do die at these earlier ages. It's less common, but it does happen. This distribution is skewed left. The left half extends further than the right half. It has a tail that extends to the left. In this case, the mode is greater than the median, is greater than the mean. So the mode is going to be around here, around 87 years old. The median, more over here. And the mean is sensitive to outliers, so the mean is going to be more over here. Okay, the mode is greater than the median, is greater than the mean. We've seen that distributions can be unimodal, bimodal, or uniform, depending on how many peaks they have. We've also seen that distributions can be symmetric, skewed left, or skewed right.